some of the stuff that we're going to be going over here, and then we'll jump right into it. Some of the advancements in 3D tooling, custom threads now in Mastercam 2021, 2D dynamic corner pretreatment, more control over Flowline machining, and 3+2 automatic roughing. So some good stuff here, well worth your time. That being said, Shane, I'm going to turn it over to you, and thank you all for attending.
All right, welcome. Thank you for coming. I recognize some names out there, people that I've worked with previously, and definitely some new ones. The first thing I'm going to talk to you about today then is the 3D lathe tooling. I grab my Mastercam part program I've got here programmed with just conventional tooling. And maybe this is something you just want to implement into your current process. It's just transitioning into the 3D tooling use. So as of right now, I've just got this program with conventional tooling. Okay. And I'm going to cover the process of defining two tools, one of which is going to be an OD turning tool. And I've got these sorted on a level here. I go to my top view. I've got the holder and the part number on one level and the insert on another. And I also have bar, holder, and insert. So let's start off first and define this OD turning tool here. So I'm going to jump to the first path then and just do it there. I could also head into the tool manager to create it, but I'll just go into the path itself. And if I right click anywhere in this white space, I can click the 3D tool. Previously it was just create tool. So create 3D tool. And I want to pull the name of the holder into here. So I'll go to my levels tab down here, and I'm going to copy this text back to Tools Designer and paste that in. I can pick what kind of particular tool it is. It's going to be general turning for this one. And tool number, I'm going to just key in 100 for now, station number 1. Okay. Then I go to the holder itself, tab here, and I want to key in that name again, and I want to grab my holder here. So if it, for some reason, turns off your level, you can turn visibility on and select it, and selection. And you grab the name of the manufacturer. This is just a Mitsubishi tool, so just paste that in here. The shank, rectangular or cylindrical. I can right click and say a length of an entity, and I can grab something on the model that defines that width, like this edge. And again. Okay, so I got my square shank there. Machine connection and graphics, if you just hover, actually show what's going to be the back side of the tool. So we're going to grab that plane there. Okay, now we go to the insert tab, fully defined there in the holder, and I want to go to new insert here. I'm going to go to my levels manager, and I'm going to turn on the insert. I'm going to copy that text back to the tool designer, and I'll swipe that and key in the insert name, and then I can grab from the graphics screen here. Grab that insert, general turning. I'm going to define it Mitsubishi and put in the code. If you had a grade that you wanted to put for the coding, you could add one here. And then I'll jump down to the definition for the insert. Corner radius is 364, so cutting definition, I want to paste in that name again. It is indeed a left-handed tool. Looks like that pulled in for us. And here would be if I needed to mate anything, but it looks like this one was mated just fine. Jump down here to cutting plane, and the cutting plane is going to be this top side plane here. Okay, and then keep an eye on the offset. Right now it's not actually at that cutting plane, it's shifted. So what we can do is right click and say Z equals Z coordinate of a point, and I'll just grab something on that plane, and that puts us in a position right, directly flat with that plane. And it's also kind of difficult here with this rake, you know, the angle the insert's cocked at to get things just so. So just keep in mind what geometry you're going to pull from the tool to define the thing. Okay. The boundary looks fine. Every now and then you may have to play with these tolerances to get them to pull in, but they look just fine. Mounting position, here's where you would toy with this if for some reason this thing weren't properly orientated, but it is a vertical orientation. It is a top turret. Tool angle, if we needed one, left spindle clockwise. So that all looks good. Jump down into here and it's looking for the tool center. I'm going to grab this option here from the tangent entities, and I can just grab this line, this line. That puts us in a position. Check your cut and plunge. They look good. Quadrant looks good, but nonetheless, if you needed to change, you could. And then the last thing is feeds and speeds. So let's key in maybe 14 inches per rev and spindle speed of 500 surface foot. And then I'll green check. There's my insert, green check. So with the interface in 2021, what you'll notice too is if you need to go back in and edit tool, you've lost some of your control in here, but just know that if you right click and say edit on the insert itself, you can get back in here more, more of your parameters. So keep that in mind. That was a new enhancement for 2021. Nonetheless, there's the tool. It brought in my new feed rate, speed. If it doesn't, you can right click, reinitialize feeds and speeds to pull in from the tool. And I'll green check. And then for these next two paths, I've got face, rough and finish, rough the OD. Just grab my tool, green check. And then the last one is the finish of the OD. Tool, regen, and I'm halfway there. I've got my OD turning defined. Now I want to save my program and I want to jump into that boring. So I'll go ahead and turn on those two levels, one of which again is the holder and one is the insert. Okay, back to my toolpath and expand my parameters for toolpath 4. And I want to right click, say create 3D tool again. I'll go to level so I can pull in my text here. Copy, back to Tool Designer, paste that in. I'm going to grab this pull down and I'm going to say it's a boring bar. And let's call this one 200 station 2. Then I'll click on the holder tab and I want to swipe that and paste in my name. I want to grab here. That's the model we're going to grab. End selection. General turning, let's put it to boring bar. Manufacturer, let's say Mitsubishi and paste that in. And the shank is cylindrical. It's round. And it's looking for a diameter. I can go grab a diameter of an arc, D equals diameter of an arc, by right-clicking. And I'll zoom in, click that guy. So 1-inch shank, and machine connection, again, is going to be that back face. Grab here. And click on that face. If I go right click, I'm back to top. Orientation is a little off, that's okay. That'll get defined further into the development. So I'll click insert and I want to grab a new insert here. Back to my level manager and I'm going to grab the insert here, the name, copy, tool designer. I paste that in, and I'm going to grab my insert here. That one. General turning. Yeah, it's not threading. It's not grooving and parting. Manufacturer code. And again, if you wanted to input that type of grade, the coding that's on that. Then down to the next tab for the insert definition, I'm going to say 3 divided by 64, 3/64 corner radius. And if we look at this guy, it is a right-hand tool. Okay. On down to align the face of the insert with the bar. It looks like it's aligned well, so we'll skip past that. Cutting plane for a bar is going to be this topside plane or something flat orientated with that. So I'll grab this plane. If I go back to the top plane, what we see here then is it's flat. There, it needs to be right dead center of that radius. So if I go to offset, right click, I can say z equals z coordinate of a point, and I'll just grab this arc center. So that shifts me up right in a position, right dead center of that tool shank. And it's starting to look closer. Orientation. Let's see here. We jump down to the next one. The boundary, again, it's pulled in. We don't need to play with any of the tolerance. Let's go right down here to orientation, and let's say this is horizontal. Okay. And it is a top turret. It is a left spindle. What happens if we click counterclockwise? Okay. And then what about reverse? Now we're in a position. So we've got this thing just as it would orientate in the machine. We've got our tool nose radius defined. Everything is set. Jump into here, and let's grab this tangent entities here again. This one, this one. Okay, cut and plunge look like these are defined incorrect, so we can switch those here. Cutting in and plunging up. Looks good. And the last thing would be your feeds and speeds. I'll go ahead and key in maybe 14 FPT, 500 SFM. Also with the coolant, and you've got the two different styles of coolant, standard and X style coolant, custom coolant. And I'll go ahead and set both of those for flood on with green check. Insert, green check. And my bar is selected, feed and speed pulled in, green check. And again there. And I want to finish with this. I want to go a little slower. Feed, a little faster on the constant surface footage. Regen. I'll move my arrow down, save my program, and I'm going to go into verify. Maybe before I do so, I'm going to turn on my part solid and my term profile. Jump into verify. Now we've got a nice 3D tool representation with the clamp and everything. Play that. Looks good. I'm going to go to the right view and just kind of stare down that bore. You know, you see some value in actually defining this thing or collision check. So it looks like it passes the test. Everything is defined properly. Looks good. Last thing I wanted to kind of touch on is inspection points here in this file. Tool inspection. So maybe you've got this tight bore where you're worried about these passes. You'd rather take a pass and come out to a position of maybe 10 inches absolute after every pass. You can even put a comment down here to maybe clear the chips. green check, and regen. And it should show up here in backplot even too. So all the way out to 10 inches and a stop each time. Okay. 3D tools. All right. Grab up this PowerPoint and advance to the next thing I'm going to cover here, custom thread. Okay. Brand new for 2021. Where it's handy, defining non-standard or unstandard threads in your favor. Ability to use tools other than standard threading tools. Right. So let me pull up Mastercam and let me drop that file in. Custom thread. All right, I've got this 3D model defined. This is our chain profile of our thread, and our pitch is 2 threads, or 2 inches pitch, you know, so half a thread per inch. Okay, and I've already got a path defined here, but let's go through the process of creating one. So if we expand our gallery, custom thread, so thread is still there. We just got this additional feature, custom thread. And a lot going on in here. It's kind of tabs similar to 3D Lathe tool. So we've got our option to select a tool. We can select one from a library, create a new tool, create a 3D tool, set your coolant, so on and so forth. I'm going to just grab this 55-degree DNMG tool. Next, I go down and I can define my axis combination for guys with the main and sub or lower upper. You can manage that right here. Let's just say this is the left upper axis combination. Work offsets, tool orientation, so on and so forth are here. So for this, we'll just skip past that. Also with the home position, forcing a tool change, comment for your path is all defined in here. Then we get into the actual shape. So there's parametric and there's options here for defining. So rope, buttress, square, trapezoidal. This particular application, we're going to grab a chain. We can't define it as parametric. So as soon as we click the chain radio button, we get an option here to grab. So I'm going to grab it. And I'll start my chain here. End it there. Green check. And then the pitch, and pay attention to that thread per inch, it's going to be a half. Okay. Rough motion. I have this disabled. We're just going to rough and finish with one go. So it's just going to slightly step in and advance, you know, small depth cuts, just following this profile. So this I have disabled. I just go straight into finishing. And I've got a kind of modest spindle speed. Keep in mind that, you know, that FPR, feet per rev, is going to be 2 inches. So that thing's going to be moving. Step 5 thou, 1 depth cut at 0.19. Cut direction. You can do an alternating cut or a negative or a positive, I suppose, depending on the hand of your tool. And then stock to leave, we're going to take this thing right to net. Acceleration clearance, I just keyed in a 1 manual. Overcut amount, what I grabbed is the distance from edge to edge. So we can do X equals, or rather, let's do S equals distance between 2 points. And I'll grab from here to here. And that gets the span of that chain, an X. So that's how far I'm going to have to feed off. And then also start and end position. So end position is going to be the back of the model and start is the beginning. So I can right click and say Z equals coordinate of a point and grab the end. Okay. Multi-start, if it were, it's not. It's a single start thread, but you could define that in here. Tool inspection, if maybe you did have a multi-start thread and you wanted to do one and stop and check the tool before you proceed to the next, you can turn that on. Stock clearance, I've left this to 0.1. G1, it looks like this covers your miscellaneous integers if you have to control any of those. And then just tool display. So I'm going to green check, and there's our path. Okay, let's put this thing in verify and take a look. Looks like it matches our part model pretty well. In fact, what I've done here is I've imported an STL for comparison. Because that verify takes a significant amount of time because of all that computation. And this is what's coming out of verify. All right. Let's see what we got. Yeah, and this will take a while to demonstrate. So, all right, back to the PowerPoint. Corner pre-treat. So if anyone's run into some of the issues, you know, since the dawn of the dynamic cut, in fact, I've actually created a case with CNC software for one issue where when it rolls external corners, it just has this tendency to engage more than your radial step over. So this is a way to knock those corners off and then continue machining. So clearing corners for a better tool path, managing radial engagement on external corners, and reduce the amount of thin-walled islands. All right, go back to Mastercam, and I'm going to load in that corner pre-treatments. I've got this file here, the Toolpath. I've got a path already on it. Let's replicate what I've already created. So the dynamic mill toolpath in our 2D gallery. Hopefully everyone's putting this to use. It's a great path. I'm going to grab it there. I'm not going to worry about machining regions. Reason being is I've defined that with my stock model. So that's already set. I do want a from outside because it is an external profile. It's not a pocket. And I just want to select avoidance regions. And I want this outer fillet. I can always push to the wall by just subtracting that fillet radius. So green check, preview chain. If I go from top, let's see a decent preview here. Green check. I'm going to pick that tool, a 1/2 inch, 3 times diameter flute length, right? So it's 1.5 inches, and then to our washout 1 3/4 inches. And what I want to use is all of my flute length when I can after I've treated my corners. So for first, I just want to demonstrate what it does, you know, without using corner pretreatment. So I've got a 10% step over, and I've subtracted 55 thousandths from the walls because we got a 60 thou fillet, so that's going to leave 5 thousandths on the walls and 5 thousandths on the floors. I did a micro lift distance of 25 thousandths at 500 inches per minute, and I turned on my gap to when avoiding a boundary or exceeding a distance. Okay. I'm not using depth cuts. I want to take it in one depth. I'm not using entry motion. I just skip right down to linking parameters, and I've got these set to 1 inch absolute, 0.1 absolute, and I use the clearance only at the start end. Feed plane, incremental 25 thousandths. Top of stock, absolute 0, and the depth, absolute minus 1.475. Okay, planes, top, and coolant, let's say flood on and green check. And that path calculates. I'm going to save my program, and if I pull up backplot and I slow this down, hit play. Maybe play again, and now I can just kind of zoom in on this corner so we can see what's going on. You see this, you know, this step over here. Now, if I roll that corner, you can see that radial engagement on that corner is pretty excessive, right? So if you're going more than 100% times D and your flute length, you're liable to just break that tool. It's just too much engagement. So if we go back into the parameters of that cut and go to corner pretreatments, we can turn that on. And as far as the selection of parameters here, I'm going to maintain the same step over. I think 10% is fine. I just want to do 3 step downs. And then this value here, let me just put this to start 100%. Also, I've got control over my feed rate, conventional feed rate, and spindle speed. Conventional is if you grab zigzag or you wanted to conventionally cut. But I'm going to leave that alone. I'm going to green check and regen. I'm going to go to my top plane. And now, if I kind of just skew this thing, we see we got 3 depth cuts. And we knocked off those corners. So if I play that through backplot, and then we get into standard machining practice from there. Okay, and then the one value that I wanted to address here then is this guy. So the more I crank this up, if I put this at 200%, it's just going to knock a bigger corner on that guy. Regen. Backplot. And now I just got a more of an excessive corner before I proceed into the standard practice of machining. All right, save, run that through verify. Looks good. All right. Thank you, everyone. And I'll pass the mic over to Brian Gleeson now, and he's going to show you a few more features in Mastercam 2021 that I'd like to share with you.
Thank you, Shane. Good job. Get some new advantages in controlling Flowline in 2021. I know maybe Flowline's a favorite of everybody. Maybe you have license restrictions, and so it's one of the few toolpaths you get to use for 3D. But we have this, it's called UV Reflow. So we can come in and actually start adjusting how the surfaces are going to be. So I'm starting off with the solid model. Nothing else. Go check my levels. I got one entity. I'm going to go ahead and create a new level. We'll call that. Surface. And I'm going to go into surfaces and say from solid, go ahead and pick this guy in selection. Turn off that level. So basically looks the same. If I go to wireframe, we're going to see the actual UV of the surface. So if I did a Flowline toolpath, it would just zigzag along or across. Maybe I wanted to change the angle of it. I go to UV Reflow right here. So it's under the Surfaces tab over to the right. We can change the flow line of the surface. We have 2 options. One of the easier ones is going to be just the rotation angle. I can go ahead, click on the angle, rotate it to whatever angle I want. So 45. Maybe I didn't want to come straight across. I wanted to have my toolpath come at a 45-degree angle. So now the UV has been rotated about that. So if I go ahead and go into Toolpath, and I pick my flow line, select my surface, can look at the flow line of the toolpath now, so we can change the cut direction, step direction. But I wasn't restricted to just the shape of the UV of that solid. Now I have options to control the surface. Got my 1/2-inch ball. You can just go ahead and leave most of these settings at default. Click OK. And voila, I now have a flow line at 45 degrees to that surface. So if we backplot that, lower it down a little bit so we can actually see what's going on. So I've seen it where people like to come 45-degree one angle and then do another toolpath at the opposite. So do a little crisscross cut on there. Some options, maybe we want to come off that surface a little bit. If I go into the parameters, go into gap settings, I can add tangential line length. So maybe I'll do 300. Region that. Now we see that we're actually coming off the edge before it does the transition. So a little better transitioning. You're not going to get the movement marks on the surface itself. I didn't have to go and extend any surfaces. That one would be a fun one to extend and retrim. And nice smooth toolpath. Now, something else that you may come across and work is, what if draw a little hole on here. I'm gonna go to my surfaces and trim the curves. Now, what if there was a hole in the middle of that surface? I just regen as is. Get all these lift ups in there, right? Now, I could go try to fill that hole with a flat boundary or something like that, and it's not going to be the greatest, and it's extra work. Inside of this toolpath, I go back to my gap settings. We have a gap size, so I can set a distance that it's just going to go directly over. So if I set that gap size to 1 inch, the same as the diameter of that hole. Regen that. Now my tool is staying down. It's not doing all the lift ups to go over the hole. So good. Nice smooth tool path. Didn't have to do any whole lot of extra work. Just change some parameters. Just skipping right over. And voila. Lots of advantages with the UV thing. We can change it to boundaries if we needed it to actually take the shape of we need to change the UV to take the shape of a boundary. There's that option. It's not going to come out always as expected. If you try to use a flat boundary, it gets a little wild. I wanted to do wireframe, curve. Oh, forgot to go to 3D. So we go back to surfaces and did reflow and do it by boundary. So I'll select my surface, select some chains, and now it restored it back to following the edges of the actual surface for the UV flow. So 2 new options in there to get a little better control over your surfaces. Alrighty. So we have a brand new toolpath. It's the 3+2 automatic roughing. Now, anything that's automatic can get a little wild. So benefits, the easy button isn't always that easy. Understanding vectors and being able to simplify the vectors. I'm going to go ahead, jump on in. So we have a part here. We got, and we have stock. We have our tooling. So if I were to just hit, let's see, I got my machine in here. All right. And we have our 3+2 if you expand the gallery right here. Now, it takes a little bit of time to process. It's going to be looking at all sides. We're just going to hop down to the tool axis control. Now, if I left it at automatic and said you can move as much as 90 degrees and search every 10 degrees. So it's going to try to find as many flats and how it can rough out with these parameters and get something that looks sort of like this. So that's the, if I just let Mastercam do all the thinking for me, easy button. And that's probably not a toolpath that I'd really want to put out. So I'm going to go ahead and go back into our start and show some ways that we can do to control this. So go ahead and do 3+2 auto. And first thing we gotta do is add some model geometry. I'm gonna add a little bit of stock since we're roughing. I'm gonna just go ahead and select my whole part. Now, it doesn't have avoidance geometry set or an option in there, so I'm gonna add one. So we'll go ahead and say add new group. Say I want to say 25 thousandths off, and I'll select a color for that. And I'm going to go ahead and select entities. So when you select avoidance, if I just selected the fixture geometry, the solids, it's still going to see a gap in here. So what I went and did is I created an avoidance solid model. So I'm just going to use that, make sure that it's retracting, getting all the way around. I'm going to select that whole solid. In selection, we have our tool, give it any comments. Got a certain holder, stock. So it's going to be looking at the stock that we used as a job setup. I use the stock solid and set that up into our job setup already. On the cut pattern, so we can do offset, parallel, and dynamic motion. We can set that to using a 1/2-inch cutter, so I'm going to use full depth engagement. Step over, 25%, so 62,000 step over. I'm going to expand this, and I want to kind of like the OptiRough. Side note, this is not OptiRough. It's not using all the same dynamic tool motion the OptiRough would use. But if I had to program something really quick, this would definitely get it done. going to turn on my depth step. And I'm going to say incremental. So it's going to step back up any angled surface. So this is basically like taking a 2D dynamic and turning it into a OptiRough. And I'm going to say, yeah, we're going to go ahead and pay attention to any flats that are 62 thousandths or step over. I'm going to jump back up here. I'm going to turn on silhouette boundary, and I want it to start doing intermediate slices after each depth step. So now that I turned on silhouette containment, it turns on another option tab down here. I'm just going to go off part silhouette. Now on the tool axis control, we have automatic, manual, or semi-automatic. I'm going to go ahead and do a manual. So now I have control of which sides I want to come in and rough from. So I can right click in here and say select tool plane. I'm going to say solid phase. I'll pick a solid phase and tilt that around to the actual vector that I want it to be in. Say okay. I want it to come from the back side. Add each side. And I'm going to do one more. Solid phase. All right. So the order that all these vectors are in are the order that it's going to start machining from. I'm going to have it start from the sides first and then look at the top if there's anything left over. So I'm going to go ahead and move this one down to the bottom. So now it's going to look at basically the C90 side first and then work its way down. Collision control, I'm going to say check machining surfaces and in-process stock. Linking, I'm going to leave as default. Well, actually, I'm going to say machining direction, and I do like the automatic on the height. So it's going to just make sure that it's getting enough clearance. Going to skip down to roughing, and it has this kind of a gap control in here as well. So it's going to try to link anything that's 50 times the tool diameter. So I don't know if I need to go in every 5 inches. I'm going to just go ahead and drop that down to 10. And it's all the settings I'm going to mess with it on this one. Go ahead and say okay. While it's thinking, I can turn off my avoidance, get a good clear picture of what's going on. So it takes a little bit to process. It's looking at all angles. It's trying to calculate how much stock's left over. It's doing all that work all at once. So previous versions, I would have done a OptiRough on one side, create a stock model, OptiRough on the next side, stock model, and so forth. I'm going to tell you that with the OptiRough and the stock model is going to be a little bit quicker, a little more accurate, less air cutting. But if you needed to get a roughing pass out really fast, this is a great option. The other thing that's good about this toolpath is it's vector driven. So if you came up with a process that worked really good with this 3+2 automatic and you went to your old exported that operation, saved it, saying this is my aluminum 3+2 automatic. Anytime you got a part that's similar to that same part file, you can go ahead and import it in, and you don't need to recreate planes or reassociate planes. You're just going to have to reassociate the geometry to go with it. So definitely pretty cool feature with it being vector driven. So we get our roughing passes. Automatic decided it needed to go way up. And if we wanted to, I'm gonna go ahead and go to my machine tab, check out some simulation. I got my Haas. I'm gonna make sure that I'm plenty of distance away from the table. I'm gonna say position that up to 10 fixtures. We'll do from level 4, use Mastercam stock definition, and I'll go ahead and use external post. That's going to simulate the posted code and not just the NCI file. Going to process for a little bit. Since it's actually using the post, it takes a little bit longer to think. If you have the cool pop-ups in your post, you're still going to have to answer them. Give it a sec to think. Hopefully this pops up on the right screen. I don't know if a lot of you guys are using machine simulation. I find it's definitely very valuable when you're trying to do multi-axis toolpath. You get a lot better idea of your clearances, idea of where your fixtures and everything else are going to have to be mounted. If you need a spacer block, like I tell you on this part, I would have needed a spacer underneath that fixture to make sure I'm going to clear the table on rotation. But gives you a lot better idea of what the toolpath is going to look like. Backplot, you know, the tool's moving around the part. Machine simulation, it's actually parts moving and the tool is in the spindle. Definitely appreciate it. And we're almost there. And of course, it pops up on the wrong screen. I'll drag this over here in a sec. Still processing a bit. So we got our Haas. Turn on the housing if we wanted to. Turn it off. But I'm gonna go ahead. I'll slow it down just a hair. See what this toolpath ends up looking like. So that was the first side I picked for the roughing. It's gonna rough as far down as it can reach. Speed it up so we're not here all day. So I knew there was material there, knew how far it needed to go out. So it's going to reach as far as possible. And then when we rotate, it's going to see that it might have a few air cuts, but it's still going to be stock aware of what's left over. So doing definitely most of the work from this one side. So was stock aware, knew how much was left over on which side. Not as much excess on the, you can reach over there. Then as it starts getting, after each rotation has less material, it'll start getting through there quicker. And again, if I let that be on the table, on the platter, I would have been crashing. That's how I knew I had to lift it up in position. So I would have needed to build a block underneath that. I would have known that without the simulation, or until the operator yelled at me. Oh, should have one more rotation. Oop. Head home. Alrighty. So that's 3+2. Very useful. If you get some settings you really like, make sure to go ahead and do the old. Oh, did I open the wrong one? Your parameters, you have the save parameters button. So once you get a bunch of settings that you like, go ahead and hit that save or import export. It's a great tool option for that.